Hi everyone. This lecture is on data, machine learning, and cloud computing, which is the basis of today's AI systems. AI actually can be used for different applications. For this one, it's more for entertainment and fun. You can actually try this game. You can click on the link and you can start drawings. You can draw a cookie, you can draw a rabbit, watermelon, okay? Before you finish drawing, probably the AI system can know, okay, what you're drawing actually. So how come you can do these tasks? Okay, it's basically have a collection of related drawings from a lot of people, okay, and learn from these drawings from others so that it can recognize your drawings. So it's kind of for fun. AI can also be used, okay, for some applications, okay, to help people who are suffering from some disabilities. Okay. For example, some people cannot hear, okay, they are deaf, and they can make use of AI to help them to communicate. So let's take a look at this video. It's for lip reading.
Play red in X-ray cell.
So from this video clips, you probably see that the AI system can analyze the movement of the mouth and then try to understand what is being spoken, and then can help the people, okay, who cannot hear to communicate better, to have better support for their daily life. Okay. And other than this, of course, you know that AI system can help a car or can make a car to self-drive. In order to do this, okay, the AI system needs to automatically recognize different cars on the road, different pedestrians, road sign, in order to drive safely. Okay. Other than self-driving, in the medical domain, it can also analyze different medical images and then provide some suggestions for clinicians. For sports, okay, it can also analyze how different athletes, okay, to do the sport, how well they are doing, and what kind of strategies they can use in the future, okay, to increase the chance to win in a game. So in order to do all this, okay, the AI system in these days try to make use of big data. To better recognize cars, they use lots of images of different cars. Okay, in order to analyze the medical images, they also need to have the images from different patients, so that, okay, the system can make use of all these patients' records to help a new patient. So for this lecture, it contains three main parts. The first one, okay, we will cover some really basic concepts in machine learning that include data, features, and some key steps, okay, of carrying our machine learning tasks. And then we will talk about different types of machine learning algorithms. There are actually more than one type. And then finally, we have to touch on deep learning, which is one of the most popular machine learning algorithm, which is being used in many successful applications. Okay, so first of all, what is machine learning? Okay. Machine learning is a subfield of artificial intelligence. If you recall in the previous lecture, there are different subfields under AI, okay, which includes, say, computer visions, natural language processing, and so on and so forth. Machine learning is being one of it. Okay. So it aims at learning to perform some tasks from experience. And here we're talking experience recorded in data. If you have some data, if the machine learning try to learn from this data to perform some specific tasks, which will be further described afterwards. And the nice thing is that it learns from data, which means that there's no need to, explicitly program, write very detailed program to perform those tasks. Sometimes I would say machine learning is just like cooking. Okay, so if you have some good ingredients, okay, and good way of doing cooking, then you can produce good dishes. So we start with ingredients. We all know do good cooking. Ingredients is just so important. Ingredients for machine learning is data. Okay, if we have good data, then there's a high chance that we can have good machine learning models at the end. So data, just like ingredients for cooking dishes, there can be different types. Okay, so typical types of data is some numerical data. For example, you have sensor. Okay, you have temperature sensor. You may have humidity sensor. Then you can sense the humidity, the temperature using the sensor, and then the numbers become numerical data. So one type of data. Another type is also very common. Images, right? Images is essentially an array of pixel values. I'll have another slide to elaborate a little bit these types of data. And in addition, we also have audio recordings, of course, right? When we speak, the waveform moving up and down. So these are the audio signal, okay, audio data. Then, of course, we also have a document which contain characters, words, they are organized in paragraphs. Okay, so in order to form another type of data type. Okay, and also we have a video, we have a social network. For social network, we're not just having posts, but we have also recorded how people are connected with each other. Okay, for those of you who know a little bit about graph, is essentially a graph structure. So different types of data. So this is an example about an image, which is essentially an array of pixel values. So I pick a particular picture elements from the image on the left, okay, and then highlight three numbers: 120, 50, and 25. 120 is a value corresponding to the red component. 50 corresponding to the green components, and then 25 corresponding to the blue components. You probably know, okay, different combination of these red, green, blue components will give you different colors. Okay, so one pixel values can have three numbers, and there are so many pixel values of the whole images, right? So there are lots of numbers. So for an image, for our brain, we can easily figure out, okay, what is this image is about. How about machines? We just like cooking, okay, we have to process those ingredients. We have to prepare the ingredients in a way that we can make them ready for cooking, right? And similar case, machine learning. We have to process or prepare the data so that they are ready for machine learning. And then what do we mean by processing data and make them ready for machine learning? So there's a steps that we need to do, which is called feature extraction. Feature extractions. From all the data, we have to extract some features, which actually will become some numbers as well, but numbers become much easier to interpret. So let's take an example for this line. On the left-hand side, then you have two images. One is cat, one is dog, right? Of course, you can look at the pixel, at the red, green, blue values for each pixel, lots of numbers, okay? But it's very difficult to analyze, so we have to extract some features from it. Here, I decided two features. The first feature is related to the eyes of the image. Okay, either it's from dog or from cat. The next feature is related to the spatial organizations of the eyes and the nose. Okay, so based on these features, you probably can see. Okay, when we compare cats and dogs, the iris of the cats is smaller. Okay, and when you compare the distance between the eyes and the nose, okay, and the cat, this distance for the cat cat's eye and cat's nose is smaller when you compare to the dog. Based on these two design, okay, or observations, okay, I come up with two formula. Okay, so don't worry, it's actually very simple. Okay, so feature one, I try to compute the area of the iris divided by the areas of the eyes. Okay, for this ratio, I think it's not very difficult to see that for cats, okay, this ratio values, this feature one values will be smaller. For dog, it will be larger. Okay, smaller for cat, larger for dog, feature one. And for feature two, the distance from the eyes to the nose, I put it in the denominator. Okay, so if the distance between the eyes to the nose is larger, the feature two will be smaller. Okay, so in that case, feature two, the values for cats will be larger. The feature two values for the dog will be smaller. Okay. If we try to, so this is a very simple plot, right? The y-axis is feature one, and the x-axis is a feature two. Okay. I try to plot the two features of dot, okay, on this 2D coordinate plane. Okay. So as you recall, feature one, the values of dot should be larger, and then for dot, the feature two should be smaller. So that's why you have this plot here. I use red color to indicate that it belongs to dog. Okay. You do the same thing for the cat's image. Okay. Feature one, okay, it should be small, iris small, right? And the feature two should be larger because the smaller distance between the eyes and the nose we put in the denominator. So the values of feature two smaller, larger. Okay. So then they form the dot, the blue dot that you see on the slide. If we repeat that for more dogs and more cats, I think it's quite reasonable that, right? The dots of another dog, okay, will be close to each other. So the dots from the cat should also be close to each other because they are the special features of dogs and cats. And we call this 2D plane, we also use another term, we call it a feature space. Feature space, okay? And we try to project the input image, okay? Input image data on the feature space is the terminologies that we used. And you repeat this for many images of dogs and cats, you probably will come up with this plot, right? And so you see the red dots are grouped together and the blue dots are grouped together. And machine learning algorithm actually work on this space. Start from the very original data, and then do this projection is pre-process it. Okay, and afterwards, okay, after the pre-processing, okay, preparation, the data is ready, okay, for machine learning algorithm to work on. And the task that we have just described, okay, yeah, designing good features, is called feature engineering. Designing good features for an application, this task is called feature engineering. Okay, so then what are the principles for designing good features? Of course, if the inputs have similar labels, right, say images of dogs, of course you hope that the features values will be close to each other, similar to each other. Okay, if the labels are different, dog versus cat, you want the features values to be as different as possible in order to do a good jobs afterwards, right? Okay, so we are after preparing well the data and ingredient, prepare them so ready for cooking, ready for machine learning. Before we move on, there are some terminologies that we need to understand. So people call machine learning algorithm. Basically, it refers to the software that know how to learn from training data. and you can understand it as the recipe, okay? How to cook. Even though we want to cook a certain type of dishes, okay, the different recipe. Okay, so machine learning algorithm actually is the kind of recipe. And then the next term is machine learning model. Okay, so machine learning algorithm is used, okay, to learn from the data, and then the output, the resulting outcome is the model. Okay, it's the machine learning model. For example, there can be a set of rules, okay, that can carry out a task. So the final dish is the machine learning model. The way to cook the recipe, okay, is the machine learning algorithm. Okay, so there are two notes, okay, for you to understand better the concept. Okay. So suppose, okay, let's think about cooking. Okay, and same recipe. Suppose I present you recipe and I present another students the same recipe. Okay, does not mean that both of you can do the same dish. Okay, it depends on the ingredients. If I give one students good quality ingredients and another student not so good qualities, okay, even though the same therapy, the dish will not be the same. Similar case for machine learning. Okay, so for machine learning, okay, even the same machine learning algorithm, okay, it does not always give the same machine learning models if the training data is different, right? And someone say garbage in, garbage out. Okay? If the quality of the data is not good, ingredient is not good, the final machine learning models probably will not be good. So another scenario is that, okay, so I give you same quality ingredients, same quality data set, okay, for training. Okay, but then it will not always give you the same machine learning model, of course, if the recipe is different, if the machine learning algorithm is different. Okay, so we have to understand this. So we have to pick the right algorithms. We have to prepare some good quality data, and then hopefully again we can get a good machine learning models as the outcome. Okay, so with this context, that probably explains why these are the key steps of machine learning. Okay, so number one, okay, so of course we need some way to gather the data. Okay, there's some ethical issue possibly related to that part. Okay, so we have to collect the data responsibly and properly. At the same time, we have to guarantee its quality. Okay, we probably will talk about the ethical discussions in the second part of this course. And afterwards, okay, as I mentioned, we have to prepare and pre-process and process those data, which means cleansing, formatting, okay, and then extract the features, okay, and then we have to leave 80% for training and 20% for testing. What do we really mean by that? Okay, think about this, and I will discuss a bit of a view during the lecture. And then the third step is, of course, as I mentioned, you have to pick a good recipe, choose a proper or relevant machine learning algorithms, and then with that, you can start cooking. You can train the models, okay, until you get a good model as the outcome. And then you can evaluate. If it's not good enough, you can repeat. Step 5 is evaluation and testing, and step 6, you can still tune some parameters. That could be difficult for you to understand. It's just like when we cook, we may cook it rapidly or cook it very, very slowly. The quality of the food probably will not be the same, right? Similarly, for machine learning models. And one of the tunings that we can do is learning rate. Learning faster or learning slower. And we will touch on this, okay, also in the lab sections, okay. And then, of course, after finishing, you come up with a good enough machine learning model. You can use it to predict some unseen data, put it into productions. Okay, so we hopefully by now, okay, you understand the key concept, data, features, and some key steps of machine learning. Now we move to the 3 major types of machine learning. They are supervised learning, unsupervised learning, and reinforcement learning. Actually, they are just mimicking how human beings learn. Okay, sometimes we have a supervisor to give us advice on every single step. Okay, so as to finish a task, okay, which is called supervised learning. And sometimes we don't have a supervisor, but we explore the world and then we learn some patterns. Okay, something repeat itself. There must be some regularities. Okay, I will explain a bit more of this afterwards. Okay. And also sometimes we learn through reinforcement. That is, okay, we try to work on it, it works, and then again, it doesn't work. Okay, we learn through this kind of experience. Okay. So let me provide you a bit more details so that you can understand the difference among these 3 3 types of machine learning. So supervised learnings, as if you have a supervisor, tell you a lot more advices. So this supervised learning is to learn a machine learning model and then take an input and give a good desired output. How to do this? Okay, it's based on example input-output pairs. Okay, let me explain using this line. So on the left-hand side, you see 3 fruits, right? Some pears, some apples. So you prepare this, okay? And on the right-hand side, you see a table, and each row is basically 1 data item, okay? And here you have 1,000 data items altogether, which form the data set. And for each data items, you see you have input and output, right? For input, okay, we have 2 features. We can have more, but for these examples, we only keep 2 features. Okay. What are these 2 features? One is color, one is shape. Okay, so for the first data item, the 2 input features is basically red color, and then the shape like a circle. And then we also know, okay, it's corresponding to an apple. That's the output. We provide this label. Okay. And the second data item, color design is like yellow, and the shape is like a 0. And then we also have the label is basically a pear. And we can prepare, collect and prepare the data set this way, input-output pair, okay? Then form this data set. Notice that we call this kind of data set labeled data set. Since we provide the labels, we know what each data item is corresponding to. Okay, so you see this feature space before for cats and dogs, and this time this feature space is for apples and pear. Okay, so for the 2 features, okay, if the feature 1 corresponds to the color, if the color is close to red, the value will be small. If this is close to, say, yellow, the value will be large. Okay, and so this is the design of the feature 1. And for feature 2, okay, if it's like a circle, then the value will be small. If it's like a shape of a pear, like say digit 8, then the value will be larger. Okay. And then we can plot the data on this feature space. Then you see that the apples will be grouped together. And again, we use red color to indicate the apple labels, right? And use the green color to indicate the pear labels. Okay. And also you see that we can draw a line between these 2 groups of data points, right? We call it decision boundary. Okay. So based on the decision boundaries, I would say that whatever images, right, of fruit, if this is on top of the decision boundary, we consider them to be pear. Whatever below this boundary, we consider it to be an apple. Okay. So make use of the data and a label to design this decision boundary. Okay. is the task of supervised learning. Then you may ask me, William, it's very easy to draw this line just using our eyeball, right? Can we teach a computer to do the same things? The answer is yes. Okay, and then what's happening behind the scene? Okay, in order to do this, okay, there are three main steps as shown on this line. Okay, actually, it first start with some random line. Okay, from machine learning, it will just randomly draw a line. Okay, of course, randomly draw a line for the decision boundary, it will make a lot of mistakes, right? And then there will be a lot of error. And we know the error because the data items are labeled, right? It is supposed to be apple, but then you put a pear there, so we know that there's an error. Okay, and then the machine learning algorithm, the second stage is to adjust the line so as to reduce the errors, to make better and better predictions. Maybe I shouldn't say there are 3 steps, there are actually many steps. Okay, the line actually move around so as to make as a small error overall as possible. Okay, and hopefully eventually it can make all the correct predictions. Okay, so the line will keep moving during the machine learning process. So that's about key concepts about supervised learnings. Can we learn without labels? Okay, so basically, supervised learning would like to discover rules and patterns. Rules and patterns may appear in the form of cluster and groups. Okay? And then you may say, without labels, without supervision, it's very hard to learn. Okay? However, we notice that even babies, okay, can learn without labels. Okay? For newborn baby, it's very hard for the parents to communicate with them using language, right? Explain to them, this is daytime, this is nighttime. Okay, it's very hard to explain that. But however, babies can easily, notice that there are 2 periods of time. They don't know the labels. They don't know whether this is daytime or nighttime, but they notice that there are 2 different periods of time. Okay, the first period probably is, they see the night, the environment is a bit noisy, and then they can eat, and then they can play. Okay, and that period of time is dark for most of the time. Okay, quiet, and also most of the activity is sleepy. Okay, so even though without explaining to them, okay, without giving them labels, they can actually learn. There are 2 different periods of time. Okay. How to do that is also not difficult. We come back to this feature space, and then you see this dot. These are the data set. And you also notice that I removed the color. Okay? The color indicates the labels. Here I removed the color, so no labels. But by observing how these data points, how the data sets are being organized, we actually see that there are 2 groups, right? Cluster 1 and cluster 2. Okay, there are 2 groups of data points, 2 groups of data items. Okay, they are close to each other among each group. Applications. We have so many photos in these days. Okay, I don't think I can use my lifetime to provide label for each of the photos, which also make organizing photo album quite challenging. I'm sorry. Okay. However, if we can do clustering, if we can group the photos, okay, so all the photos of my daughters are grouped together, or the photos of particular friends of mine are grouped together, it will be much easier, okay, for me to locate and find the photos that I want without providing any labels at all. Okay, and which is actually possible, okay, by using unsupervised learning. And another possible application is movie recommendations. Okay, as I probably watch some movies, and then and some other people, okay, in say Netflix, okay, they are also watching their own decide the movies. Okay, and if we have similar records of movie watching, okay, so probably we will be grouped together. Okay, then I can get some suggestions of what movies could interest me by looking at the same groups of user. Okay, what do they watch recently? Okay, so I don't know them. Okay, I don't provide any labels about they are my friends. Okay, it's just that we watch the movies. Our movie records are similar, and we are grouped together. Okay, and make use of unsupervised learning. Again, no labels. The third type, okay, as I mentioned, is reinforcement learning. Okay, so most likely it's try to learn how to do some action or to make some decisions in an environment automatically, okay, and so that it can gain high reward. That is, in the long run, you can gain some things. One of the best example is chess playings. Okay, so we can play chess with many people, many opponents. Okay, by win a game, lose a game, win a game, lose a game. We bit by bit learn how to play well for chess game. Okay, it's very hard to explain to people. Okay, what exact move you should make under different situations and different scenarios, right? So reinforcement learning is that, okay, just based on win or lose, okay, and try to learn the best move under different situations. Another example is essay writing. Okay, so suppose you write essay and then you send it to me, and I do not give you detailed comments. I only give you grade. But this is an A grade essay, and this is a F grade essay, or this is a B grade essay. I don't give you detailed comments. Yeah, if you can learn to write better just by observing those grades, so you are exercising what reinforcement learning. Okay, so with this, I hope that you understand there are how many types of machine learning? 3 types. And they are different in a way that I've just explained. Okay, try and see whether you can repeat this explanation to yourself as well. Now, the last topic is on deep learning, okay, which is one of the most popular machine learning algorithms. That's why I have to highlight it a bit in this lecture. If you start using machine learning, or if some people start using machine learning, I put in this slide headings. You're moving from just a cook, just someone know machine learning, to a chef. Okay, you can do machine learning in a very professional manner, okay, because this is very powerful. You probably recall this slide. Okay, we have this in one of the lectures, okay, giving an overview of AI. So deep learning is actually following the connectionist approach. It's modern AI. Okay, so now I provide a bit more details about this connectionist AI. It designed how it works by making reference to our brain. Okay, so let's understand or recall a bit about our brain. Our brain contains many neurons, right? One neuron is essentially a cell. Okay, but this cell is very special. It can take input, can be stimulated with some nerve ending, and then it can trigger, and then it can send out some electric pulse, right? So these are special types of cell, okay, which normally we call neurons, okay, and they are interconnected. Okay? It's not just single cell; they are interconnected. So that's why I say our brain is a network of neurons. And for the nerve ending that I mentioned, there are 2 names, which is for neurons to take input. Okay, it's from the nerve ending which we call dendrite. Okay, if a neuron is being triggered, it will send out stimulations. Okay, it will send out the stimulation through axon. Okay. So if you look at the pictures on the right, okay, dendrite on the left, axon on the right. Okay, dendrite take external stimulations as input, and the output is basically through axon, which will further stimulate the other neurons. Okay, so this is just one neuron, okay, that you can see on the right hand side, and there are many neurons and they're interconnected. Okay, how many? A lot. So when we learn, okay, the connections of these neurons will change, and the connections of these neurons will be strengthened by experience and use. That is, if we experience something more repeatedly and more often and use it more often, the connections of the corresponding neurons will change, and this is how learning starts. Okay, some more in details. Okay, so initially our brain, okay, there are some connections. They are temporary connected. Okay, and how they're connected? They have connected through the constructs, what we call synapse. Okay, synapse. So if a neuron is fired, that's what I explained before, they can, after taking some stimulations, they will be fired. Okay, and then the synapse are connecting different neurons. Okay, so this kind of electric pulse will go from one neuron to another neuron. The stimulation will go from one neuron to another neuron. Okay, through this synapse, because synapse is the connectors. Okay. With this kind of stimulations propagating out repeatedly, the connection established by this synapse will become stabilized through this strengthening, will be stabilized and become permanent. Okay, then we start to have some permanent skill learned, start to have some permanent memory learned. Okay, and this process of building new connections and tearing out some unused one is very crucial process happening in our brain for learning. Okay, and deep learning try to mimic these processes, okay, to develop their model architecture, model structures, and also the machine learning algorithms. And its earlier name is called artificial neural networks. I think you know the reasons behind, because it's mimic how human neural network works. Okay, and also if as we mentioned, right, in our brain there are many neurons. Again, for artificial neural network, it tried to come up with many small processing units like neurons that connected together, so that one unit can connect to another unit and connect to another unit. And this kind of neurons are organized into layers. And in these deep learning models, they can have very deep, a lot of layers. Okay? So you have many neurons and artificial ones connected together, and each of these is processing elements. Okay? Because it's got so deep. Okay, that's why people use the term deep learning models. Okay. And then up to this point, you will say, oh, it's from biology, neuroscience, and then this kind of pictures. Okay, it could be very far from us. Okay, it could be something that is just happenings in the universities, lectures. As a matter of fact, it's not. NVIDIA, you probably heard about that. Google, Meta, lots of AI, IT company providing AI services, they make use of deep learning model, which you probably are using every single day. Okay, one more slide to explain to you why deep learning is so powerful. Okay, let's go back to this feature space. You put on the right hand side, okay, upper part, the upper port, you see that there are two groups of data, right? Red and blue. I explained to you that supervised learning, they try to learn a decision boundary, try to separate the two classes, blue from red, right? And from these examples, you can see that just drawing a line, there's no way to perfectly put them into two parts, right? You will make some error. You cannot make all the dots on one side to have the same color. It's impossible for this data set. we're just talking about 2 features here, right? If we move on to say 100 features, which is very common in these days in different real-world applications, okay, it's super difficult. Deep learning models, you see the plot, okay, on the right, the lower one. You see that if we can draw the decision boundary in a way that's being shown, okay, make it more flexible so that you can actually separate the blue dot, okay, from the red one perfectly without making any error. Okay, what kind of models can make this flexible decision boundary? Deep learnings can do that, okay, and they can do that very well. So actually, some more explanation regarding why deep learning is so powerful. Because it's so powerful, if we use the cooking as the metaphor, it is a big kitchen. That kitchens, normally we call it cloud. Okay? I think in these days, it's very not difficult to know that we need cloud computing. Okay? So this has to be in the cloud. No, if the data set is small, if the machine learning model is small, we can just do it in our own computer, laptop, even mobile phone. Okay, but however, if the data set is very big models, then we need cloud that provide computational power and also storage. Okay, who provide this kind of service? That include NVIDIA's, Google's, Meta, Amazon, Adyen, and there are many others. Okay, so with that, okay, I hope that it provides you overall summary of what machine learning is about. Okay, you try to learn how to carry out tasks based on experience in particular data. Okay, without specific tasks being explicitly programmed. There's many things, right? If you collect the data, train it, then you can perform some tasks. You will experience that in the upcoming lab sections. Okay, so what being covered? Okay, some key steps of the machine learning. Okay, on the left hand side, the picture. And in the middle, you see 3 types of machine learning. And then on the right, okay, you see that deep learning. Okay, many layers of small processing units can give you a very powerful models. And these are some references, okay, that you may want to get more information from that. Okay. With that, it concludes this lecture.